Have you ever wondered how the largest planet in our solar system, Jupiter, came into existence? This is a tale that takes us back around 4.5 billion years, to the dawn of our solar system. In the early stages of our solar system, the Sun, still in its infancy, was surrounded by a spinning disk of gas and dust. This was the protoplanetary disk, the birthplace of planets. As the Sun began to grow, its gravitational force pulled in the dust and gas surrounding it, leaving behind only the material that was too far away to be consumed. This remaining material, rich in hydrogen and helium, began to clump together, forming the seeds of what would become the planets. Among these seeds, one stood out. It was destined to become Jupiter. This seed was far enough from the Sun to avoid being swallowed, but close enough to attract a significant amount of the protoplanetary disk's mass. As this seed grew, it reached a point where it was massive enough to hold onto its own gas, creating a thick atmosphere. This was a turning point. Now, not only was it attracting solid material, but also gas from the protoplanetary disk. The more gas it captured, the more its gravity increased, leading to a runaway effect. This process allowed Jupiter to grow to a size more than 300 times that of Earth. Jupiter's formation was swift. In just a few million years, it had consumed most of the gas and dust left in the protoplanetary disk. Its rapid growth had a significant impact on the rest of the solar system, shaping the orbits of other developing planets and even preventing the formation of other gas giants. From a swirling disk of gas and dust, Jupiter began its journey as the giant of our solar system. Its genesis, a testament to the dynamic and ever-changing nature of the cosmos, reminds us of the grandeur and complexity of the universe we are a part of. Now imagine what Jupiter, a planet more than 300 times the size of Earth, is made of. At first glance, you might think it's just a colossal, swirling ball of gas and storms, but there's more to it than meets the eye. Jupiter, like our Sun, is primarily composed of hydrogen and helium. These light, abundant elements make up about 90% and 10% of Jupiter's makeup, respectively. This similarity to the Sun isn't surprising, considering both were formed from the same primordial material that gave birth to our solar system. But let's delve deeper. Beneath the thick layers of hydrogen and helium, we find trace amounts of other elements. These include heavier compounds like methane, water, and ammonia. These compounds lend Jupiter its distinctive vibrant bands and colossal storms, like the famous Great Red Spot. Then, we come to the question of whether Jupiter has a solid core or not. Current scientific consensus suggests that it does. However, the size and exact composition of this core remain subjects of ongoing debate. Some theories propose that the core is about 3 to 20 times the mass of Earth, composed largely of rock and metal. Yet other theories suggest that the core could be more diffuse, mingled with the surrounding layers of metallic hydrogen. This metallic hydrogen layer, by the way, is a fascinating aspect of Jupiter's composition. Under the immense pressure of Jupiter's gravity, hydrogen behaves like a metal, conducting electricity and creating the planet's powerful magnetic field. So, what we see when we look at Jupiter is just the tip of the iceberg. Beneath those mesmerizing cloud bands and violent storms, there's a world of pressure, metallic hydrogen, and potentially a rocky heart. Jupiter, a gas giant with a potentially rocky heart, holds many mysteries beneath its cloud bands. How has humanity unlocked the secrets of this distant, colossal planet? Our journey to Jupiter, the fifth planet from the Sun, began in the early 70s. NASA's Pioneer 10 and 11 missions were the first to venture into the outer solar system, giving us our initial close-up views of Jupiter and its moons. These pioneers of space exploration revealed the planet's intense magnetic field and the lethal radiation belts that surround it. In the late 70s, the Voyager missions, Voyager 1 and 2, followed. They provided us with unprecedented detail of the planet's complex weather systems, including the Great Red Spot, a storm larger than Earth that has been raging for centuries. Jupiter's faint ring system was also discovered, a delicate halo of dust particles that encircle the planet. The Galileo spacecraft, launched in the late 80s, gave us a more intimate look at Jupiter. It dropped a probe into the Jovian atmosphere, revealing surprising details about its composition and winds. The mission also confirmed that Jupiter has a small, dense core, surrounded by a deep atmosphere of mostly hydrogen and helium. More recently, the Juno mission has been orbiting Jupiter since 2016. The spacecraft has been studying the planet's magnetic field, atmosphere, and structure in exquisite detail. Juno's findings suggest that Jupiter's core is fuzzy, a mix of rock and metallic hydrogen, and that its atmospheric winds penetrate deep into the planet. Looking to the future, NASA's planned Europa Clipper mission will focus on one of Jupiter's intriguing moons. Europa, and the European Space Agency's JUICE mission will explore the Jovian system, with a particular focus on its largest moons. Each mission has been a step forward, shedding light on the mysteries of the solar system's largest planet. From revealing its intense magnetic field and complex storm systems to probing its deep atmosphere and dense core, we've unlocked a wealth of knowledge about this gas giant. Through the eyes of these spacecraft, we've begun to unravel the enigma that is Jupiter. Did you know that Jupiter has a family of its own, a retinue of moons that could rival a solar system? Indeed, Jupiter is not a solitary planet. Orbiting around it are a staggering 79 known moons, each with its own unique characteristics. But today, let's focus on the four largest ones, also known as the Galilean moons: Io, Europa, Ganymede, and Callisto. First up, meet Io. It's the most volcanically active body in our solar system. With over 400 active volcanoes, Io is continuously being resurfaced, making it a fascinating world of fire and brimstone. Next, we have Europa. Now, Europa is a world of intrigue and mystery. Beneath its icy surface, scientists believe there lies a deep, salty ocean. This makes Europa a hot contender in the search for extraterrestrial life. After all, where there's water, there might be life. Ganymede, the third moon, holds the title for the largest moon in our solar system. It's even bigger than the planet Mercury. Ganymede is also the only moon known to have its own magnetic field. And just like its sister moon Europa, Ganymede is believed to have an internal ocean of liquid water. Finally, let's talk about Callisto. It's the most heavily cratered object in our solar system. Callisto's ancient surface is a silent testament to the history of our solar system, bearing the scars of billions of years of cosmic collisions. But it's not just their individual characteristics that make these moons interesting. It's also their potential for life. With the discovery of water on Europa and Ganymede, the possibility of life existing beyond Earth has become more plausible. Could there be alien microbes swimming in the oceans of these icy moons? Or perhaps even more complex organisms? In the cold darkness of space, Jupiter's moons might hold the key to one of humanity's biggest questions. Are we alone? Could the mighty Jupiter, situated millions of miles away, be playing the role of Earth's cosmic shield? It's a fascinating thought, isn't it? Let's delve into the idea of Jupiter as Earth's celestial protector. Picture the solar system as a busy highway filled with celestial bodies, asteroids, and comets, all zooming around at breathtaking speeds. Now imagine a massive vacuum cleaner that's constantly on the job, sucking up most of the dangerous debris that comes its way. That's Jupiter for you. Jupiter, being the largest planet in our solar system, possesses a gravitational field so strong that it acts like a celestial magnet. It attracts and captures a significant chunk of the space debris that hurtles around in our solar system. This includes asteroids and comets that could potentially pose a threat to our home planet, Earth. This theory of Jupiter as a vacuum cleaner was first proposed by scientists in the late 20th century. They noticed that Jupiter's powerful gravitational pull was diverting or capturing many celestial bodies that entered its sphere of influence. By doing so, Jupiter effectively reduces the amount of space debris that could stray into Earth's path, thereby minimizing the risk of catastrophic collisions. Of course, this doesn't mean Earth is entirely safe from space debris. We still have meteor showers and occasional asteroid flybys, but without Jupiter's gravitational might, it's likely that the Earth would be subject to far more frequent and potentially devastating impacts. Now, isn't that a comforting thought? Despite being over 400 million miles away, Jupiter might be playing a crucial role in preserving life as we know it on Earth. In the grand scheme of the solar system, Jupiter might be more than just a neighboring planet. It could be our guardian, our protector in the vast expanse of space. So the next time you gaze at the night sky and spot Jupiter's bright glow, remember to give a nod of thanks to our cosmic shield.